We're going to finish up chapter 3 by looking at density. Density is defined as mass over volume, so our equation is D equals M divided by V. And actually from this equation we can get two more. If I want to solve for mass, I would take density times volume, or if I wanted to solve for volume, I would take mass divided by density. That's just doing some algebra to get those different equations. Density is intensive property. Depends on the composition of the substance, not the size of the sample. A couple examples. Density of pure water is 1 gram per mil. Density of lithium, which is a metal, is 0.53 grams per mil. Will lithium float or sink in water? Well, it's less dense than water, and if something is less dense, it floats. So even though lithium is a metal, it will float in water based on those densities. I throw in this density and temperature just because whenever you see the density of something measured, you will always see a corresponding temperature. Normally, the temperature that densities are measured at is 25 degrees Celsius. So you have density equals mass divided by volume. The volume changes as the temperature changes. The volume of most substances goes up as the temperature goes up. But the mass is constant. The mass is how much stuff is there. Therefore, the density generally decreases as temperature goes up. So again, I throw this in here just to say that whenever you see a density measurement, you will also see a corresponding temperature. Let's go through a couple examples with density. Fairly straightforward. If I want to calculate the density here of a metal, it's just mass divided by volume. We have a mass of 612 grams. A volume of 245 centimeters cubed. So my density, when I do the calculation, I get a density of 2.49796. We have to round this off to sig figs. 612 has 3 sig figs, 245 has 3 sig figs. We're dividing, so my answer has to have 3 sig figs. So 2.49796 would be rounded to 3 sig figs. We're going to round it up, 2.50, and then write your units, grams per centimeter cubed. Next problem, I have grams, and I have the density, and I want to find the volume. So my equation is density equals mass divided by volume. Well, I want to get volume by itself, so here's how you do it algebraically. You multiply both sides by volume. That cancels V over here, and you get mass equals volume times density. But I want to get volume by itself, so I need to divide by density. I will get rid of that. And so I have volume equals mass over density. Rearrange the equation, plug in our numbers. Mass 14.8 grams, density 2.34 grams per centimeter cubed. Pay attention to sig figs, because I start off with 14.8, which has 3. I'm dividing by 2.34, which has 3. So my answer in the calculator has to come out with 3 sig figs. Do the math. 3 sig figs would round to 6.32. And then my volume, centimeters cubed. A 68 gram bar of gold is cut in 3 equal pieces. How does the density of each piece compare to the density of the original? Density is intensive. So the density of each 3 pieces would be the same as the original. They're exactly the same. They're equal densities. Regardless of the size of the sample, whether it's 1/3 of 68 grams or it's the whole 68 grams, they have the exact same density because it's the exact same material. In this case, it's gold. One more. Plastic ball has a volume 19.7 centimeters cubed and a mass 15.8. Will the ball sink or float in a container of gasoline? Well, if I want to figure out if it sinks or floats, I need to find density. Go ahead and perform the calculation. We got mass 15.8 grams. Volume we have 3 sig figs in both of those measurements, so my answer has to be rounded to 3 sig figs. 0.802, and the units here are grams per centimeter cubed. Now a centimeter cubed is the same thing as a milliliter, so I could also say 0.802 grams per ml because gasoline is in grams per ml. So the ball has a density of 0.802, gasoline has a density of 0.67, so the ball is a greater density, so that means it will, in this case, the ball will sink in a container of gasoline.